Okay, so today we're going to kind of, I guess, in a sense, like add another layer to this idea of a polynomial. Okay, as I was watching some of you finish your map test yesterday, I saw people that had questions that looked like this, where it was like a binomial. Maybe it was 2x plus 5, and the other one was 4x minus 6 or something like that, and they asked you to multiply those two together. Anybody get one like that? Can you remember having like something like that? Okay. So if that was you, you were thankful that it was multiple choice at this point, right? Because you're like, I don't know the answer to that, right? So I'll guess. Oh, this one looks good, right? Well, we're getting there. This is something that we'll look at on Monday. Today, though, we're going to kind of look at it just at the first level. And that first level would say, well, what happens if you have a polynomial and you want to multiply it by a monomial? Meaning more than one multiplied by one, okay? If you think about that, in its very elementary state, it could look like this. If I just left the 5 there. What property puts these things together? The distributive property, right? We all draw our rainbow arcs, right? We put those things together, okay? Well, we're going to go a little bit bigger than what if it's just a number, a constant out there? What if it's got a variable? What if that variable's got a power? Those kind of things. So that's what we're going to look at today. You see, we're going to look at a couple of examples. Example 3 is missing on purpose. Okay, I didn't like it. I took it out. Okay, so I didn't want it. We did this already. Okay, so those are our goals. Can we multiply this idea? And then lastly, can we solve an equation that kind of has this inside of it? We haven't solved an equation in a while, right? We've been dealing with kind of some other ideas, so to speak, along the way. So this isn't really what we're trying to do today. This is actually something from the last chapter I kind of brought back because we need this. And if we can do this, we're golden today. Okay. Now, could you add these two together? Good, because the powers are different. So no, you could not add them together. But I'm not adding. I'm multiplying here. And I can multiply them as long as I remember how do you multiply variables with powers. You have to add the powers. Now, what do you do with the coefficients? You multiply them. So in the first one, 6 times 3, 18. And the variable, y to the 8th, right? That's as difficult as it gets today. It'll look different, but that idea right there is as much as we have to be able to do. Okay? Which part is not looking right to you? Oh. Well, okay. That's okay. So that's honestly going to be one of our hardest parts. When am I supposed to add? When am I supposed to multiply? When am I supposed to do this? When am I supposed to do that? Like that part gets difficult. It's like grocery shopping without a cart. Like at some point you just can't hold all that stuff in your hands anymore. And so it's hard to remember where that stuff goes. Well, okay, so there you go, right? That's that whole like, how do I keep this straight? Am I adding and subtracting? Because there the powers have to be the same in order for me to put them together. If I'm multiplying, yes, I add those powers. Okay. So you'll see kind of both those ideas come into play today. All right. If we look at this one here, could you add those together if there was an addition sign? Okay. So similar, but not the same, right? So no, you could not add them or subtract them if that was being asked. But multiplication I can do. Start with the coefficients. 9 times 3, 27. Now for the variables, I take those powers and I add them. So m to the 3rd, right? Because you have 1 here and you have 2 there. So m to the 3rd. And then the n's also to the 3rd. You have 2 in the first one and 1 in the second one. So n to the 3rd. Okay. And if you would pull out your chapter 7 stuff, this idea was like all over the place, right? We were kind of leading to where we're going. Okay. So one more before we kind of move on. This one looks bad, but I promise you it's really not that bad. Come on. There you go. So just coefficients, then variables that are the same. So x's, y's, z's. What do you get? We're multiplying the coefficients, but the powers we do what with? We add. We multiply the coefficients, but we add those powers. Thanks. Smags, you bust out a calculator for a third of 12, huh? Nice. I would hope you probably could have figured it. Yeah. Yep. Yes. Where did that number right there come from? This one here, the 9. You have 2, 3, 4, 5. You don't have any over there that are x's. Everything except for that y. Look at your y's one more time. Yep. There you go. Good. Very interesting. You went to the x, then the z, then the y. Your alphabet skills, huh? Yeah. All right. So starting with your coefficients, we already decided a third of 12, right? That was a 4. X to the what? To the 5th. You have a 2 and a 3. So product rule way back. Add those together, you get a 5. Y's also to the 5th. You have a 1 here and a 4 there. So that's 5. And then Z, a 2 and a 5, you get 7. Okay. Yeah. Are you wrong if they're in a different order? You're not. Typically, you would see them alphabetically. So X, Y, Z. But if your heart says Z, X, Y, then so be it. Okay. So, yeah. So you're not, we're getting that idea of standard form in there, right? Standard form is going to fall if I had something like this. 3x to the 4th minus 2x to the 5th plus 6x squared. Here, we would say that's the biggest. So this term right here should be in the front. Because this one up here is one term. There's no addition or subtraction there separating it. It's all together. Where here, you're looking at 3 different pieces. So, but again, that's one of those things like, how do I keep all this straight? Okay. We need to be like that lady that bags your groceries at Walmart, the shoppers. Have you seen those people? Or like any of the stores? They have like the coolest cart ever that has like 27 different compartments. If you know what I'm talking about? And I got this one grocery cart that's got everything heaped up on top of it, and she's got 47 boxes, and every one gets its own little thing. And I think, man, that's organization right there, right? Well, you know, it's impressive. It's impressive. All right. So here's where we're trying to go today. This isn't something necessarily that we have to do because I would hopefully believe that we could do this. We would distribute in that problem how many times? 3, right? We would, hopefully, we would go here, then to the middle, and then to the end. If I was to solve this problem, tell me something that would not change from what I currently see to my final answer. Well, the exponents, I would say yes, but something else that does not change. I mean, I think you guys are saying the same thing that I'm thinking, but when I say that, I'm thinking the variables aren't changing. Like the x squared is still going to be an x squared. The x is still going to be an x. Why is there not going to be a variable power change in this problem? True, there's no power raised to power. What am I multiplying by in this problem? A constant, a 4, right? So what changes? The coefficients and the constants. That's what change, right? We're more going to be looking at today what happens when this value outside of here isn't just a constant. Okay, and so that does mean that my variables do change. The powers on those variables do change. So let's take a look at this one here. Again, in this problem, how many distributions will I have? I will have 3. When I make my first distribution, though, to there, I'm only concerned about multiplying those 2 things together. Right, not the whole thing. So for that reason, what you see there is no different than where we were here. We're only putting 2 things together. It doesn't matter how many are inside of this parenthesis. It just unfortunately tells me how many times I have to do it. You follow that thought? So heaven forbid if there was like 8 things inside of there. That just unfortunately means what? I got to multiply a lot, 8 times, right? But I'll never do more than 2 at a time. So can you tell me the answer to those 2 multiplied together? Coefficient, and then what's my variable combination now? Evan, you got an answer for me? 6. So the 3 and the 2 gave me a 6. But what about x to the first times x to the second? What happens there? What do you do with the powers? You add them. So x to the third. Now, I go to the next one. Well, not all at the same time, one at a time. Right. So now in the next one, coefficient, which is 9, variable. Well, 1 here, 1 there. So x to the second. And then now down there. Why not? True, but I'm not adding them, right? I'm multiplying. So the 3 and the 5 are a total of 15. And then I have an x to the first here, but over here I didn't have any, so I still just have an x to the first. And you can write the 1 or not write the 1, your choice. Now, can I take any of these 3 things and add them together? Why not? Okay, so they don't have they don't match. No like terms, right? That's as good as I can get. All right. Try this one. Let's do what you come up with to that. I don't agree with that one. Uh-uh. What's that number right there?
60.
4 times 5? I'm like, maybe he wrote his 2 backwards. I don't know. You got it. Good. Good. So this last one, you are bringing a y to the third, so that would need a y to the third. 4 and 5, that should be a 20. And somehow you decided to bring a new variable in. Yeah. You just didn't like my y's. Apparently you just changed them. You got it. Yep. I think you got it right. That is correct. Who's dribbling the water bottle back here? What are you doing? Yeah, what the heck, man? I'm gonna fall. You are so close. That's a 3. So when you bring it here, that would be a 3. Yep. All right. Well, you started it off correct. 3 and 2 gave you the 5. Then you got here, you have a 3 and a 1. So this one should be 4. So that one would have a 4 on it. And then at the end, you did 4 times 5, you got 20, but you had to bring a y to the third with it. So there would be a y to the third on the end of that as well. All right. Logan, final answer to this. 12y to the 5th, so that's the first one. Minus 24y to the 4th, that's the second one. Plus 20y to the 3rd. That is the third one. Very good. Awesome. All right, 2 more and we're done. All right, let's make it a little bit bigger. Okay? Now, here's the deal. If you answer this correctly, your final answer will be a quadratic trinomial. If your answer is done correctly, it will be a quadratic trinomial. After you're done distributing, you should have 5 parts. But your final answer should only have 3. That's why it's a trinomial. You got it. Good job. Oh, okay. Just yelling at me. Y'all making fun of me today, and then you gonna yell at me. Very good. Yep. You just need. You brought these 2 together.
Yeah.
Right here.
The Y.
So you need a Y on it.
I actually.
There you got it. Watch out. That should be a 2, because those 2 together would not have. Yeah, that one didn't have one on it. Yep. 25 and 6 is not 11.
Wait, I don't even know why I put 11.
What's 25 and 6?
30, 31, 32,
31.
31.
So this one here, they each have a Y. So this should be a Y to squared. Yep. And then this 6 here because it had a 2y and a 3. That should be a 6y. So that's going to change some of those because they're going to get grouped together differently.
If you add these both together, would it be y to the second power?
No, and this will not be a 4. Remember, when you add them together because they match. So you don't change their signs. You didn't distribute here. So that gave you an 8. But y and y, that's y squared.
I didn't do that.
And you did not do that one at all. So yes, 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 yes. This one needs a y because it had a y on it right there.
Okay.
So just squeeze a y on there. All right, fine, erase that. Okay, now look at these things. Is there anything in there that's a like term that you could put together? And the answer is yes.
Yeah.
So do not do it.
Mm,
These two match.
yeah, but this one matches too.
Oh, it shouldn't. Look,
Why?
there's no y here, so that should just be to the first.
Oh.
And
But what
I'm
is
not
this?
sure why
I.
there's a 2 there. Because
Wait.
5 times 2 should just be the 10.
Yeah, but then. Oh no, well because like you said something. Yeah.
You blaming me? It's messed up. Yes, yes, yes. This 2y, and so you should be distributing here as well. Because you did here, right? 1, 2, you did those 3. So now you got to do those 2. So your first part is right. Take this off right there and go from there. All right. Good. That stays a 2 though.
Okay.
Because that's what allowed you to add them together was the fact that they were the same. All right. So here, 1 and 2. Okay. Because you were distributing in of a y. Okay. Now, at this point, though, you have 5 terms. But of those 5 terms, those 2 have the same variable, so they can be added together. These 2 have the same variable, so they can be added together. So your final answer should be a trinomial. It should have 3 parts. Which one do you put together first? Faith, yellow or green? Okay, total 28y to the second. Okay, and there now we're back to that idea of adding and subtracting from yesterday. And we don't change the power when we add or subtract. We only change the power if we are multiplying. So we got to be able to keep those 2 straight. In the green, 25 and 6, 31y, and the minus 10 on the end. Okay? All right. Now, I told you we were going to do 2, so we have 1 left. Okay? Now, here, do me a favor. Distribute out the first row and freeze. Okay? Because there's something there we need to just talk about for 2 seconds. Like when you make these distributions. Here, and there, and then freeze. How come, side note, I have to distribute that B on the second half before I add these 2 together right here?
What I have a question. So, well, like the second B, like when you distribute B to B, would it be B 1 squared?
Be B squared. Because powers are both what? 1s. So 1 and 1 gives you 2.
But it's not 2B, it's just B squared.
Correct. Because what's the coefficient in front of each? You're multiplying those, so that stays a 1. 12B.
Oh,
Come on, that was you gotta get that one.
I just gonna do that. Just like.
we there?
Yeah.
The goal of an equation is to solve, to figure out what your value is worth. We don't have the skill set yet to be able to find something when a variable has a power greater than 1. Okay, that we don't know how to handle that yet. We will. We're getting there. For us, though, in this situation, because we have the exact same variable combination, this b squared, on both sides, what happens to it? It cancels. So we're okay for right now because they went away and we still only have a variable with an exponent of 1, which we know how to solve, or at least we should know how to solve.
I don't understand why I got rid of those.
Well,
Not on the same side of the equation, not opposite yourself. Oh, subtract it.
yeah. So yeah, essentially you just minus them. Now at this point though, there are b's on both sides. So somehow all of those need to get together. Which side should we move them to? To the right side. Why do we not want to move them to the left side? Well, if you move the 2b and the minus 4b, if you move them to the left, what would be over there? Nothing. So that's our problem. Yes, sir. Absolutely. Absolutely. So I'm going to go ahead and move this negative 12 over here to join all of this and kind of just group it all into one thing right now. So what do I have with a negative 2, or excuse me, a positive 2b, a negative 4b, and a negative 12? It's a grand total of negative what? Negative 14. And on the right side, a negative 7. And this is how I solve a linear equation. I put constants on one side, I put variables on the other, and then I isolate that variable. In this case, by dividing, right? So I divide by negative 14, and I find out that b is equal to 0.5 or 1/2. What's the hard? What's the easy way? Okay. So they were all positive. Oh.
I usually like to have my variables on the left.
Yeah. Yeah, and I think that's a pretty common thought, to have my variable first and my answer second. Now, when we get into solving things that have a power greater than 1, the rules change. Okay, you don't solve them the same way. They don't look the same. You shouldn't expect to solve them the same way. So that's how we handle something that's linear, and then we get to quadratics. Well, then how does that change? This is 8-2. So we're multiplying a polynomial and a monomial. Okay, before I see you on Monday afternoon, though, there are a couple questions for you to look at. We haven't had homework in your book in quite some time. So a lot of you probably have books at home. If not, obviously use your Clever account to access your online book. Okay? Smags is going, oh, geez. All right. So all of these questions, though, and this is in classroom, so it's all there. So you don't have to write it down. You can get it from there if you want. They're all odd, so obviously your answers are available to you. Please don't come in here with a sheet of answers and tell me that you lost the work, did it in your head, blah, blah, whatever your nonsense statement would be there. Okay? And then you are going to need the trapezoid formula from your book. So you can either get it from your book or obviously you can just Google search the trapezoid formula because you will need that as well. Everybody loves Google.